This is one of the more difficult ones on here, just because you got to separate stuff. Somebody help me out. What's the little letters on there?
What maybe?
What's here?
Y.
Y is there?
Yeah. X. That together is C. And between B and C is little a.
C.
What is
B.
what B?
60 degrees on
Ah, this is getting pretty bad. I need that.
and 90 degree in C.
What do you know about this angle right here then?
It's 90
90 degrees. How about this angle?
30,
How about this angle then?
60.
So all three of these triangles, does everybody see all three triangles in that picture?
Yeah.
All three of them are what kind of triangles?
30, 60, 90.
30, 60, 90. Did they tell us any numbers anywhere? Oh, they tell us something different for each one, don't they? 28. On 28, they tell us A is 4 radical 3. So this right here is 4 radical 3. And what they want us to find, B and C. So I'm going to draw the big triangle. We're probably going to have to deal with the triangles separately here. Got the big triangle here. This side's C, this side's B. That's a right angle, that's 60 degrees. That's 30 degrees, and they tell us this side is 4 times the square root of 3. In a 30, 60, 90 triangle, you're going to have to know this on this quiz that you're getting ready to take. In a 30, 60, 90 triangle, side across from the 30-degree angle should be labeled what?
X.
X. Now we're actually going to change that, and I'm going to write that over here just real quick. And remind me, we'll go back in your notes.
So the side across from the 30.
Is always X, but we're going to change it. The 30, 60, 90, 30, 60, 90, side across from here, we had, this is before, all right? This is what you wrote in your notes. You might want to get your notes out and change this right now. The side across from the 30 degree was X, side across from the 60 degree angle was what?
2 X radical 3.
X radical 3, good. Side across from the right angle, 2x. That was before. This is what I want you to change your notes to. I mentioned this when we started this, and then I said I was going to teach it different this year. Then I figured out that it was stupid to teach it different. So change this in your notes. Instead of this is what we want. The side across from the 30-degree angle, we're going to label it L. The side across from the 60-degree angle, we're going to label L radical 3. Side across from the right angle is what then? 2L. All right? And the only reason I'm changing it is because when you got X's that you put in there and X's that they put in there, it gets confusing. Do they ever use lowercase l like this for a variable?
No.
No, so change that, and we're also going to change the 45, 45, 90s, and a 45, 45, 90. The two sides across from the 45-degree angles are labeled what?
L.
What were they labeled, sorry?
X.
X and X, right? Side across from the right angle,
X radical 2.
X times the square root of 2. Now we're going to change it to, this is a 45, 45, 90. Sides across from the 45-degree angles, we'll change them to L and L. And then across from the right angle, the hypotenuse is L radical 2. Just so there's less confusion. That's the way I've always taught it in the past, and this year I thought I'll go with the book and teach it, because they teach it with the X's. And then after doing a couple of problems, I thought that's just dumb, because it's just too confusing. So the side across from the 30 we said should be labeled what now?
L radical.
L.
Just L, right?
Yeah.
So this side's L, side across from the 60-degree angle,
L radical 3.
L radical 3 L times the square root of 3, and side across from the right angle, 2L. This is the equation we got. We now know that L equals 4 times the square root of 3. Nothing really to solve there. Don't let this confuse you. They tried to confuse you because they made the side that usually doesn't have the radical on it have the radical on it this time. All you're going to do is take that and plug it into each one of these. So if I'm looking for C here, what's 2 times 4 radical 3? What do you multiply there? Just the regular numbers, right? So 8 radical 3, that's one of your answers. I think they were looking for C, right?
B and C.
So for B, all we're going to do is we're going to take that and plug it in right here in place of L. When you plug it in there, you're going to have 4 radical 3, that's the L, times the square root of 3. This time, instead of, like up here, we multiplied the 2 and the 4. This time, what 2 numbers are we going to multiply together?
Radicals.
The radicals. What's radical 3 times radical 3?
9.
Square root of 9. Well, what is the square root of 9?
3.
So you got 4 times,
Radical 3.
not radical 3 anymore. Remember, the radical's gone now.
Oh.
4 times 3, that's 12. So how long is B? 12. So what happens is when that radical is on this side that's across from the 30-degree angle, is there end up being a radical on the side that's across from the 60-degree angle? They like to switch sides. All right? I don't want to say it that way because that'll make Wyatt think that, okay, I just turned these 2 around. And, well, it doesn't work quite that way. 29. See if I can do this up here without having to redraw this. This time they want us to find A. Don't look back at A over here because it's going to be different. All right, they want us to find A and CD. So we're looking for this segment and this one. So I'm probably going to use that little triangle right there. Ignore that straight line there. Use that little triangle. That's 60 degrees. That's 90 degrees. That's 30 degrees. And they tell us that X, that's this right here, is 3 times the square root of 3. Is that right? We're looking for A and we're looking for CD, which is this side. Side across from the 30-degree angle should be labeled what? L again, right?
Yeah.
Side across from the 60-degree angle.
L, up, 3.
Good. Side across from the right angle.
2.
Same setup as the last one, right?
What are they?
29.
I wasn't here. Only Thursday.
So these are special kinds of triangles. You got 30, 60, 90 triangles, and you got 45, 45, 90 triangles. All right? So watch, because each time you have a 30, 60, 90, it's labeled a special way, and that's what I wrote down up here. And you're just going to label it that way every time before you start anything. Then once you label it, Gunner, see how I put an L here, and they already had this here? We're going to set up an equation from whatever that is. All right? So here, our equation's pretty easy. It's just L equals 3 radical 3. Somebody help Gunner out. Is there anything to solve there?
No.
No. So we just know wherever we see L, what are we going to replace it with? 3 radical 3. All right, so over here, if I got 2 times L, you just 2 times 3 radical 3, what's that give you? 6 radical 3. So that's A. A equals 6 radical 3. That's one of our answers. Same idea over here. I plug in here, and I'm going to take 3 radical 3. We just got done doing something just like this on the other part. Times the square root of 3. What is the square root of 3 times square root of 3?
3.
Ends up just being 3, right? 3 times 3 is 9. The square root of 9 is 3. So Wyatt knows, hey, can I skip that step? Yeah. And then we got 3 on the outside. What's 3 times 3 give you? 9. So how long is segment CD? 9. Those are our 2 answers.
Did you miss a line on number 30?
Yeah, I didn't realize they had three of them that they were looking for. Number 30. They tell us A, so they tell us this side over here this time. Don't get, no, from 28, 29, is A always the same thing?
No.
No, it changes, they just use the same picture for three different problems. So A is 4 this time, so it's right here for 30 is 4. Since it's the last one, I'm gonna write up here on the other picture. CD we're trying to find, we wanna find B, and we want to find Y. Alright, so probably what we're gonna do, we're looking for these three right here in this medium-sized triangle. We're looking for the three sides in that. Well, we know this side, so if we know that side in the little triangle, can we find the other sides in the little triangle? And then we can find that other stuff. So let's use the little triangle first. That's 90, that's 60, that's 30, this is 4. Side, watch Gunner so you understand this, the side across from the 30-degree angle, every single time in a 30, 60, 90 triangle, it's just a pattern. All 30, 60, 90 triangles are basically the same triangle used over and over and over again. They either just get bigger or smaller. And this is the pattern. It always works out where this side right here, the shorter leg of the two, is half as long as the hypotenuse. And this side is always that number times the square root of 3 for the longer leg. It's just a pattern. Okay? Does that make any sense?
I don't understand it at all.
All right, so look, all you're doing, side across from the 30-degree angle every time. If I tell you the side across from the, let's draw this right here real quick. Side across from the 30-degree angle, if I tell you it's 5, all right? When we look at this pattern, if this side is 5, the hypotenuse has to be double that in every 30, 60, 90 triangle. So it's 2 times whatever that number is. So 2 times 5 would be 10. This side over here, the side across from the 60-degree angle, if this side is 5, you just put 5 in there in place of L, and it's 5 times the square root of 3. It's just a pattern. Every single time, it's just a pattern. So on this one, side across from the 30-degree angle is L, side across from the 60-degree angle is L radical 3, side across from the right angle is what? 2L. What equation can we set up this time? 2L equals 4. How do we solve that? Divide by 2. What's L equal? Once we know what L is, Gunner, once we know L is 2, that side right there across from that 30-degree angle has to be how long then? 2. So that side right there, 2. That little part from there to there is 2. This side over here, 2 times square root of 3. Now we were trying to find, we actually found one of them right there, CD, so that's, for 30, that's one of our answers. CD equals, what do we say, 2 square roots of 3? If we use this triangle, and we know that that side's 2 radical 3, that's the side across from the 30, so that's going to be our L. Side across from the 60 is L times the square root of 3, side across from the right angle is 2L. Those are the other 2 parts that we're looking for, those 2 parts right there. We know L equals 2 radical 3, and I know that this is getting to where you can't hardly see what I'm talking about now, and we'll hurry up and get through this problem. We'll do some easier ones, hopefully, Gunner, and hopefully that'll make more sense. So this side's 2 radical 3, that's the L. Well, when I stick it in down here, how long is B going to be? If it's 2 times 2 radical 3. What is 2 times 2 radical 3? 4 radical 3, so that's B. 4 radical 3. And then we got to find this side, same idea as on the other one. Plug it in right there, 2 radical 3 times 3. Somebody help me out and just tell me the final answer on that. What's 2 radical 3 times the square root of 3?
times 6.
6, all right? 3, square root of 3 times square root of 3 is 9, square root of 9. Square root of 9 is 3. 3 times 2 is 6. So how long is y? 6. That was probably the hardest one on the whole paper, right? Pick me another one. Pick me something easier so maybe it'll help Gunner before this quiz. Number 1. Somebody must like you, Gunner, because they picked a real easy one. What kind of triangle do we have here? 45, 45, 90. In a 45, 45, 90 triangle, the side across from that 45-degree angle, we're going to label what?
X.
Something right.
L.
Two.
L.
L. Side across from the other 45-degree angle.
L.
L. Side across from the right angle.
L.
L times the radical 2. Make sure you don't get that confused, because a lot of people think that, because 90 is double 45, so it's 2L. It's L times the square root of 2. This time they told us that this side right here was 8.
Yeah.
What equation can we set up from that?
8 equals L.
So L equals 8. Nothing to solve there. We just know that L equals 8. So anywhere we see L, what can we replace it with? 8. How long is this side going to be?
8.
That's one of our answers. How long is this side going to be?
8.
8 times
Radical 2.
square root of 2. Those are your 2 answers. It's just a pattern every time. So Gunnar, if I gave you this triangle, and it's a 45, 45, 90 triangle, and I told you this side down here was 12. Everybody, how long would this side be? 12. How long would this side be?
12 radical 2.
12 radical 2. And every 45, 45, 90 triangle, that's the way it is. All right? Another thing, you have a square and you draw a diagonal in the square, guess what kind of triangles are formed? 45, 45, 90. So if I told you the side of this square right here was 7, we know that this side down here is 7 because all the sides in the square are the same. And we know that this diagonal is how much? 7 times the square root of 2. So it's just a pattern. Each one of these, 30, 60, 90, 45, 45, 90, just patterns.
So, number 1, you're like, you need 3 answers.
You only want 2 answers, because they already told you this one. You want this one and that one. Yeah, okay. Oh, no, I'm sorry. Do it. You better hurry. I guess you only wanted 1 answer on number 1.
Yeah, I did ask for.
They didn't ask for the other one. They just wanted this. This was the answer number 1. My fault. Next question. 7. Problem 7. What kind of triangle do we have in number 7? 30, 60, 90. This time they want 2 answers. They tell us this side is 1/2, this is X, this is Y. These are the problems why I want to switch it to L's instead of X's and Y's, because you start throwing other X's in there and it just makes it way confusing. Side across from the 30-degree angle, we're going to label what?
L.
L. Side across from the 60-degree angle,
L radical 3.
L times the square root of 3. Side across from the right angle,
2L 2. Yeah.
L 2L. Which one do we know this time?
L.
So what's that tell us? What equation?
L equals
L equals 1/2. Anything to solve there?
No.
No. Just anywhere you see L, you're going to stick in 1/2. So right here we stick in 1/2. What's 2 times 1/2?
1.
1. So X equals what?
1.
1. That's one of our answers. Down here we stick in 1/2. Can we multiply 1/2 times the square root of 3?
No.
Now I'm going to show you the best way to write it. We could write it 1/2 times the square root of 3, and that's fine. A better way is square root of 3 over 2. Means the same thing. It's just a little shorter, simpler way. Square root of 3 over 2. Next question. And you'll see that a lot next year in Algebra 2. That's the way they write it, square root of 3 over 2. That means the same thing as 1/2 times the square root of 3. Which one?
38.
38. Might do one more after this, before this quiz. Find the perimeter of the square whose diagonal is 12. So we got a square, drawing the diagonal, and they tell us that diagonal is 12 centimeters. What kind of triangle do we have here? 45, 45, 90, and a 45, 45, 90 triangle. What should those two sides be labeled?
L.
What should the side, the hypotenuse be labeled?
L.
L radical 2. Don't get that mixed up. That's about 3 times I've heard that. Make sure it's L radical 2. What equation are we going to set up this time? L radical 2 equals 12. These are the harder ones, right? Because now you actually have to solve something. What do we do to get L by itself? Divide by the square root of 2. Remember, you guys made this easy the other day when we were covering it. So don't make it harder now just because you had a couple days to forget all about geometry. Get rid of those. You're left with L equals 12 over the square root of 2. If you get lost right here, maybe you get lucky and I'm feeling in a good mood that day, change it to a decimal and write down the decimal answer. All right? Maybe I'm not feeling all nice that day and I say, that's wrong. I'm not accepting the decimal answer. I want the exact answer. But maybe you get lucky, you never know. How do I get this radical 2 out of the denominator?
Multiply it.
Multiply top by radical 2, multiply the bottom by. Remember, they'll make this harder than it is. What's 12 times the square root of 2? 12 times the square root of 2. You can't do anything to that because one's a regular number, one's a radical. On the bottom, what's square root of 2 times square root of 2? We've done a bunch of this already. Square root of 4. What is the square root of 4? 2. Now what can you do with that?
Simplify.
What will go into both 2 and 12?
2.
2 will go into 2 once. 2 will go into 12 6 times. So you end up, after all that, you end up with L equals what?
6 radical 2.
6 radical 2. How long is this side in that square then?
Radical
6 radical 2. How long is this side? 6 radical 2. How long is this side? 6 radical 2. How long is this side? 6 radical 2. I don't even remember what the problem asks us to find.
What's the perimeter of a square?
What's the perimeter of it? How do you find the perimeter of a square?
Add all the sides.
Add up all the sides, or you could just take all the sides and do what?
Multiply it.
Multiply one of them by
4.
4. So somebody help me out. What's 4 times 6 radical 2?
36.
Only in Ian's world. What is it?
24.
Tell me the whole answer.
24 radical 2.
24 radical 2. So that's the perimeter of it. How would we find the area of the square?
6 radical 2 times 6 radical
6 radical 2 times 6 radical 2. Ignore that stray mark there. What's 6 times 6 give you?
36.
What's square root of 2 times square root of 2 give you? Square root of 4, which is just 2. What's 36 times 2 going to give you? 72. So the area would be that. They wanted the perimeter this time, not the area. One more question. Then we're taking this quiz.
Which ones we just do?
38 we just did.
21.
41? 21. We got a right angle here. This whole thing is y. This is 45. That's 11. This is x. kind of triangle is this triangle then?
Isosceles right.
45, 45, 90, which is also called an isosceles, right? What are we gonna label that side?
L.
L. What are we gonna label this side?
L.
L. How about that side?
L radical 2.
L radical 2. Now watch, I'm gonna do this one as a decimal, just because I'm being lazy right now. What's our equation we're gonna set up?
L equals, L radical 2 equals, 11.
11. How do we get L by itself?
Divided by,
Grab your calculator. You're gonna divide that side by the square root of 2, you gotta divide that side by the square root of 2. These cancel out, you're left with L equals, somebody tell me what that is as a decimal. 7.8. Anybody else get that? Yes, no, maybe? That's all right. If that's 7.8, how long is X over here? 7.8, so that's one of our answers. X equals 7.8. Then they wanted us to find Y. If that is 45 degrees, what's this angle over here?
45.
This one up here is 90, sorry, I forgot to mark that. So the big triangle is also what kind of triangle? 45, 45, 90. And we know that this side is 11. That's the side across from the 45-degree angle on that. So instead of L radical 2, that's just going to be L. So we know L equals 11. Well, how long is this whole thing going to be then? If that's the hypotenuse in that big triangle. L radical 2. Well, if L is 11, what is that? 11 radical 2.
Is that 11 or is that 1?
That's 11. That's just right. Up the board. All right, so let's.
I would have said 7.8 times 2 to get Y,
You could have. But watch.
but that's not 11.
The big.
The radical 2.
Yeah, it's true, so I guess that wouldn't have worked. The big triangle, if this angle is 45, you see the big triangle saying? That's 45. They told us that was 90. Well, what's this angle got to be? 45. They also told us this side was 11. Sides across from the 45-degree angle should be labeled L, right? Side across from the right angle, L times square root of 2. Stupid pen. What do we know about L this time? L equals 11. If L equals 11, you plug it in down here, what do you get?
11. You got L equals 7.8.
11 times the square root of 2. Now see, this is why I don't like rounding stuff off, because you're looking at that and you're thinking, well, those two aren't the same.
We're pretty close
Take 11 times the square root of 2 on your calculator.
15.5.
So it is 15.5.
It's like 15.55 or something.
Yeah.
But if you round it
Now,
up, then you go
what's
15.
7.8 times 2?
15.6.
If we wouldn't have rounded off, they would have been exact. When we rounded off at 7.8, if we wouldn't have changed it to a decimal, they would have been exact.
So is that not right?
That's not right, it's just rounded off, and it's not as exact as it once could have been if we wouldn't have rounded it. All right, get out a piece of paper. After this quiz, you're gonna lay the quiz up here in a pile. You got about, it's only 2 questions on the quiz, so it shouldn't take you real long. You got about 3 or 4 minutes to do it. There's your quiz.
The only friend you want is a cigarette.
I'll walk back here and read it for
The
you.
only friend he wants is a cigarette.
Let's just go.
Right. Stinks.
We taking this? Keep the worksheet out, we're gonna do something with it.
Burn it.
Yep. Okay, go ahead. It's on the bottom shelf if there's any left. Looks like there might be a black folder there that might have a little bit in it. Looks like I'm about done.
whenever she walked in.
Okay, yeah, but it's not here anymore.
It
That was
was
Pebble, that was Pebble side.
it was some kind of.
One hit me in the eye.
When she walked in, I'm thinking, oh my God, the world's coming to an end, because she's making it sound like it's some massive storm. Now
I did
she's
not
saying,
say that.
oh, but we can play softball.
We played
But it's
softball
golf
before.
ball, golf ball type
On this
Yeah,
one,
with that, you'd be in having an eye.
Look,
No,
it started.
hurt so bad.
It was like salt.
on the quiz, watch. On the quiz, in a 30, 60, 90 triangle, side across from the 30-degree angle should be labeled what?
L.
I can get back to it here real quick. Corner options, pin. So that side's L. Side across from the 60-degree angle should be labeled what?
L radical 3.
L radical 3. You gotta know this stuff. This isn't that hard. You just gotta make sure you're doing the pattern. Side across from the right angle,
L.
2L. Which one do we know this time?
L.
L. So L equals what?
Well,
Oh, that's what it
12. Once we know L is 12, how long is this side?
24.
2 times 12, which is 24. That was one of your answers. How long is this side?
12 radical 3.
12 radical 3. That's your other answer. That was one of the easier ones,
I
right?
still got it right, but I got the 24 one. And that makes sense.
No, that doesn't make any sense. If you, either you got it right or you got it wrong. I don't know how you
But
do it.
I didn't get 24.
What'd you get?
2. No, I got 12.
2.
I got 12.
If L is 12, what do you guys do?
Because I thought that, yeah.
In a 45, 45, 90 triangle, you might have labeled your triangle wrong, so make sure you look at that. What should those two sides be labeled?
L.
L and L. Side across from the right angle, excuse me. Which one do we know this time?
Radical 2.
So L times the square root of 2 equals 12.
Dang.
If we divide,
It's like 7 and now 1.4 maybe.
1 point, that's the square root of 2.
We like that now too.
Do
I got like 8.4.
I got 6 radical 2.
Well, yeah.
So-
I calculated, I got square root. Right now, it's like 1.4, then 1 divided by 4 is, I don't know what I got.
So if you do this,
You gotta times it, like radical 2.
times it by radical 2, this is the way Bobby got her answer apparently. That's what she's saying. What's on top?
12 radical 2.
12 radical 2, what's on bottom?
2.
Just 2. What will that reduce to?
6 radical 2.
6 radical 2. Then we do one just like this on the...
Yeah, that's what I said.
Watch out.
Oh, that was one of them? Is that what you were saying? So L equals 6 radical 2. How long is this side?
6 radical
6 radical 2. How long is this side?
2. 6 radical 2.
6 radical 2.
Sure, so I got that right.
Now, if you change that to a decimal, I want somebody change it to a decimal for me on your calculator.
I said 12.
8.4. Anybody agree with that? 8.4, is that what that is as a decimal? 8.5, something like that? Yeah, you did, you just didn't know it. You did it way back here.
I keep on forgetting how to do it that way. Like,
Other questions on the worksheet, real quick?
No. Unless 40.
Gunner's probably got some because he still looks confused. Better ask some questions. Try to understand it.
I just guessed the whole packet, so.
Huh?
I just guessed the whole packet.
You know.
So I mean, I thought it was completion grade exhaustion. So I put down,
We go over,
I'm done with completion grades for the year.
40.
Because too many people just
20.
do.
Yeah, so if you're gonna
Yeah.
guess, just might as well just not do it. What it's about to say.
20. Problem 20. Never know, you might have guessed right on a few of them. Might get some of them. Got a 60-degree angle there, a 90-degree angle there. What's this angle up here then?
30.
This part is Y, this is X, and this is 3.5. Some of you should, as soon as you see that they give you a 3.5, you should say yes, because then your answer can just be in what form? Decimal instead of radical. no matter what. If we start off with the decimal, I'd probably accept all the other answers as a decimal. So if I'm just looking at that one triangle there on the left, what kind of triangle is it?
30, 69.
30, 60, 90. In a 30, 60, 90 triangle, the side across from the 30-degree angle should be labeled what? L. Side across from the 60-degree angle?
L, radical 3.
L radical 3. Side across from the right angle? 2L.
Bless you.
What's that tell us?
L
L equals
equals
radical 3.
L equals
3.5.
3.5. I'm not sure where Ian got that radical
Sorry.
3 from on that.
L
L equals 3.5, so what's 2L?
7.
So that side is 7, that was our Y, right? So Y equals 7. On the other side, if I put in 3.5 times the square root of 3, grab your calculator, because we don't want answers that have 3.5 times the square root. If part of it's a decimal, we might as well make it all a decimal.
6.062177826.
So what's he gonna round that off to?
6.1.
6.1, is that right? Because I didn't hear what he said the first time.
6.06.
So it's a 6.1, is that, so that's X, that was Y. Next question,
42.
42.
Wait, can you?
The perimeter of an equilateral triangle. What do you know about an equilateral triangle?
All angles are
All angles are 60. What else you know about it?
All sides are equal.
All sides are equal. They say the perimeter is 39, so the perimeter of this is 39. How's that going to help us before I go any farther?
39 divided by 3.
So somebody do that. 39 divided by 3.
13.
So how long is this side?
13.
13. How long is this side? This side? Find the length of the altitude. Remember, an altitude goes from one of the corners to the opposite side, and it forms what? A right angle. If we have that, we have a 60-degree angle here, a 30 or a 90-degree angle here. What's this angle up here?
30.
30 degrees. In a 30, 60, 90 triangle, the side across from the 30-degree angle is labeled L. Side across from the 60-degree angle,
Radical 3.
L radical 3. That's what we're looking for, right? Side across from the right angle, 2L.
L equals 6.5.
So L equals, if you take that, 2L equals 13. Divide it by 2. Matt's saying that L equals 6.5. Once we know L is 6.5, how can we find this length?
6.5 radical 3.
6.5 times the square root of 3. Same idea, right? You're probably going to give what answer this time?
Decimal.
The decimal. Grab your calculator. What's 6.5 times the square root of 3?
11.2.
11.25, so just leave it that way, 11.25. That's how long that altitude is. Why might you need to know the altitude of that triangle?
Building houses.
Not anything. What might we want to find out about this triangle that we need to know that altitude? What's another word for altitude? Height. What do you need the height for? How about area? What's the area formula for area of a triangle?
Base times height.
1/2 times base times height. If we were trying to find the area there, would we need to know that height? Yeah.
Can we go,
Do we now know the height on that one? Could we find the area?
Yeah.
What was the base of the triangle?
13.
13. What was the height of the triangle?
11.8.
And so we take 0.5 times 13 times 11.25, and that would give us the area.
can we go number 19?
19.
73.125.
Is that what it came out to be? Maybe one more after this one, then we'll turn these in. 19, what kind of shape did you start off with on 19?
Square.
Square. As soon as you draw a diagonal in a square, what kind of triangles are there?
45, 45.
45, 45, 90. Watch Gunner, because I'm going to show you. Everybody's going, oh, I don't know. Start using those radicals and I get lost. I'm going to show you the easier way, sort of the other pattern that I was hoping some people would pick up on their own without me having to tell them. Because if Silas picks it up on his own, then he remembers it. If I tell him, he probably doesn't remember it, right?
One of those lucky numbers, 28.
That's 28 right there in a 45, 45, 90 triangle. First of all, before I go any farther, I labeled this angle 45. Well, that was what? Look at your paper. That's X. So we already know one of our answers is X equals what?
45.
45. That's one of our answers. That was an easy one. This is why we're looking for it. In a 45, 45, 90 triangle, the side across from the 45-degree angle should be labeled what?
L.
L. Side across from the other 45-degree angle?
L.
L. So if we find L, that's going to be Y, right?
Yeah.
Same thing. Side across from the right angle?
L.
Oops. L times the square root of 2. That's where our equation is going to come from. L radical 2 equals 28. This time I don't want the decimal answer because I want you to try to see the pattern here. I divide both sides by the square root of 2. These cancel. You're left with L equals 28
Radical 2.
over radical 2. What do you multiply the top and bottom by?
Radical 2.
Radical 2. What's left on top?
28. Radical 2.
28 radical 2. What's on bottom?
2.
Just 2. Ignore that stupid straight mark there. What can you do right here?
Divided.
What do you end up with?
14.
14 times the square root of 2. See if I see a pattern there? If that diagonal was 28,
Half.
it's half. It's not just half though. It's not just 14. It's 14
Radical 2.
times the square root of 2. So if I gave you this, told you this was 6,
3 radical 2.
this side over here is going to be 3 radical 2. What if I gave you another one and that's supposed to be a square? Drew in this diagonal and I told you that diagonal was 20. How long is this side going to be? 10 radical 2. Now the bad thing is if they give you an odd number, is that going to work out so well? No, because then it's a decimal and you probably want to change everything into decimal. So what's Y on this one?
14 radical 2.
14 radical 2. So X was 45, Y was 14 radical 2. Next question, last one. That's enough.
Number 26.
26. What kind of triangle do we have in 26?
36.
30, 60, 90. This is A, this is B, this is C. Let's see, on 26 they told us that B was what? 15? That's 15. This is C down here. We want to find A and C. Side across from the 30-degree angle should be labeled what?
L.
L. Side across from the 60-degree angle?
L radical 3.
L radical 3. Side across from the right angle? 2L. What equation can we set up?
2L divided by
2L equals 15. Divide by 2. What's that give you?
7.5.
7.5. How long is, or what is A then?
7.5.
So that's part of our answer. Now some of you will like this better because when we take that 7.5 and we plug it in right there for L,
Yeah, decimal.
you got a decimal out front, so just change the whole thing into a decimal. What's 7.5 times the square root of 3?
12.99.
So almost what? And we'll say 13.0. How come 13.0? Don't tell me that 0 doesn't mean anything. That shows somebody that you rounded it, right? It shows that it's not an exact answer. All right, make sure your names are on those and pass them over to Mr. Lindsay. And I'll be over there, collect them here in 1 second, Mr. Lindsay. Go ahead and start copying this down once I get to it. Got to watch closely today. Still patterns. Make sure you don't get confused on these. These shouldn't, they're not real difficult, but they're sort of confusing. your title here. Might want to write the title. Draw altitude to hypotenuse. What is a hypotenuse?
The longest side of the rectangle.
Side across from what?
Right angle.
The right angle. What's an altitude?
The height of the rectangle.
Okay, what's an altitude do? Explain it to me.
It shows the
Goes from a corner to where?
vertex
That's the corner, that's the vertex.
up to like
The
midpoint.
center of
Opposite side, now does it go to the midpoint?
No.
Not necessarily. What's it do when it gets to that opposite side?
But it makes right
That'd be a
angle.
midpoint. It forms a
Right angle.
right angle. So with altitude, you gotta remember, it forms a right angle. Goes from a corner to the opposite side and forms a right angle. Everybody have that much?
Yep.
Yes, no, maybe?
Yeah, the title.
You got it?
Title?
No, Matt doesn't have it.
What we're gonna cover, identify, what's that symbol right there mean?
Similar.
Similar triangles. Find geometric means. Don't think, all of you think, still got that fifth grade mentality sometimes, and you think every time somebody says mean, it means add them all up and divide by how many of them there are. There's many, many different kinds of means in math, and your fifth grade teacher should have told you that. They probably did. Be able to use altitude to hypotenuse theorems. There's two of those we're going to talk about. Everybody got it now?
Yeah.
Draw this.
My window was broke and I had to like push it up. And it was leaking. But I fixed it. Like we won our game. We won our game Saturday. We played North and we were losing and I was in half and I scored 2 runs and I tied it up and then Savannah hit one of the defense. Cause it sounds cooler. So it was 7-5. We needed over there. But guess who got
All right, on this, if an altitude is drawn to a hypotenuse, so watch what happens here. We have a right triangle. If, Bobby, focus. If an altitude is drawn to a hypotenuse, so we have that, that's our altitude. What's it going to come down here and form? Or over here and form? A right angle. All right, so it's going to form a right angle right there. Draw that in. Anytime that we draw that altitude going from this right angle to the hypotenuse, notice it forms how many triangles now? How many total?
2.
Total. There's 3 total triangles. Guess what's true about all 3 of those triangles? They're all similar, and that's what we're going to write right here. Is we're going to name those similar triangles. So we're going to write triangle something. Somebody name the big triangle for me. A, B, C, I heard. Doesn't matter really how we name the first one. What matters is that we match up the others. Now here's where you got to be careful. In the big triangle, when you go to match them up, I always look for where the right angle is. What's the right angle in the big triangle? C. So So when I match it up with the other ones, the right angles have to match up.
It would be ADC.
All right, now,
Or AC.
let's look at this small one right here.
It'd be ADC.
Which one's the right angle?
D.
D.
Oh.
So where's D gonna go?
Last.
Left.
Very last. Then we look at A. A in the big triangle, A was bigger than the other angle, right? So that came first. What's the bigger angle in triangle ADC? This one or angle C?
A.
The A. So A is gonna come first in this one also. Then what's gotta come second? C. So ACD. Now let's do this triangle.
Next would be like CBE.
Which one's the right angle this time?
D.
D, so that's at the very end. And then we matched up A. A in the big triangle was the bigger of the two remaining angles. Which one's the bigger, C or B? C. And then what comes second then?
B.
Those are our three similar triangles. Now, we're not going to do a whole lot with the fact that those are similar, but you should be able to pick them out because we did that a couple of chapters ago. The last chapter. Was it last chapter? What was the last chapter? So be able to pick out those similar triangles. Now, what we are going to do with that is set up proportions like we did when we were talking about similar triangles. But these proportions hopefully will be a little simpler just because they're going to tell you exactly what to put here, exactly what to put there, what to put there, what to put there, and you just have to pick them out from the picture. All right? First thing, the geometric mean, write this down, geometric mean. What you learned in the past was called the arithmetic mean. When you added up all the numbers and divided by how many of them there are, that's called the arithmetic mean. The geometric mean is something a little different. I'll give you a second to write that down. Find the geometric mean, and we're going to do these three examples, and that should be enough to show you how to do it. It's not real difficult. If something's the geometric mean, what that tells you is it's the square between two other numbers. And we'll talk about what that's telling you. This is the easiest way to do it. You got a number on top, the geometric mean goes on bottom, geometric mean on top, some other number on bottom. Remember when you're talking about, and this is one of the bonus questions on the last test, I asked you what were these two numbers called? Does anybody remember? Started with an E. Extremes. These two were the extremes. These two were called the means. Extremes and means. When you have a geometric mean, that's telling you that this number that's in this spot and this number that's in this spot are exactly the same. So if there's a 5 here, what's there going to be there? 5. That's all it is. All right? This is another way to write it. A and B, whatever the two numbers are. And notice that you got X here, X there. They're both exactly the same. Geometric mean. So if I go to set up proportion on this first one, where's that 9 go? Right here. Where's the 4 go? Down here. Two numbers go there. Guess what goes in these two spots? X and X. And we're going to solve that. When I cross multiply, what do I get when I cross multiply that way? Come on now.
Squared.
X squared, thank you.
Okay.
What do I get when I multiply that way?
36.
36. How do I solve that?
Take square root.
Take square root. What's square root of x squared?
X equals 6.
X, and it's just x equals 6.
Okay.
So what fits in here in this proportion for the geometric mean? 6. So what you're saying is 6 is the geometric mean for the two numbers 9 and 4. Set up this next one. What goes on top right here?
10.
10. What goes on bottom?
X.
What goes on top over here?
40.
Cross multiply, what do we get that one? X squared. What do we get the other one? 400. Now what?
Square radical.
Take the square root of 400. These cancel out. What are you left with? Grab your calculator. Grab your calculator, Ian.
Perfect squares.
Quick guessing.
20.
20. Even if it's a perfect square number, if you don't know what it is, then you're no good to guess. Next one, if I do this one, what goes right here?
9.
9. What goes here? Yeah, that's the number. X. What goes here?
5. Oh, my bad, 5.
5.
We cross multiply, we get that way.
45.
X squared. What do we get that way?
45.
45. Now, when we take the square root, what's different about this one?
It's a decimal.
Alright, and I don't want a decimal. Gotta be able to break these down. So we take the square root of 45. We got our list up here. What's a perfect square number that'll divide evenly into 45?
9.
9. 9 times what?
5.
What is the square root of 9?
3.
So that comes out of the radical. What stays under the radical?
5.
So what's our answer?
3.
3 over 5.
3 radical 5. That would be the geometric mean for 9 and 5. 3 radical 5. You gotta be able to break stuff down that way. We've been doing it this whole chapter. We did a little bit last chapter. Alright, write this down. Geometric mean, notice, this one says geometric mean. There's two actual theorems that are called the geometric mean theorems. One of them's altitude theorem. The other one's going to be the lake theorem. We'll talk about it here in a minute. Write this down. This picture is going to be very, very important, and we're going to write down some stuff over here. I'm going to move this. Don't do that. Move this. Get it up here out of the way. Very important that you draw that picture, and I'm going to add some stuff to that picture, and that's going to be the key to all this. So make sure you don't just lose focus after you write that down. Alright, on this. If an altitude is drawn to the hypotenuse, then the altitude is the geometric mean of the two parts the hypotenuse is split into. So notice here I have a right triangle. Where's my altitude going to be drawn? From what to what? C to D. And I left D on there. Probably shouldn't be on there yet, but so that's our altitude. What do we know about the altitude? It comes down here and it forms what? Right angles, 90 degrees. So we have that. So we got that altitude. Notice when that altitude comes down here, What did it do to this side?
I mean, it's like,
Split it into two parts. Now, are those two parts even? No, not necessarily. But we have those two parts. And what it's going to do, it's going to set up an equation. Right? And this is what it is. This proportion. Write that down. Very important. Look at what I have here. Part 1 over altitude, altitude over part 2. If you look at this picture, should you be able to pick out those parts and just stick in there what you know?
yep.
Hopefully. So all you're going to do, you're going to put this part right there, this part right there, the length of the altitude here, length of the altitude there. It's the geometric mean. That number, those two numbers here and here should be exactly the same. Now a lot of times the altitude will be what you're looking for, so it'll be an X. The other way that you could write this, if I cross multiply here, what's altitude times altitude? Altitude squared. So another way you could write that equation, altitude squared equals part 1 times part 2. Sometimes setting up the proportions easier, sometimes writing it out the other way is easier. Yeah. Yeah, I couldn't find the actual dot, so I just used a little box that looks like a dot. So part 1 over altitude, altitude over part 2, or altitude squared equals part 1 times part 2. Not too difficult, right? Because they're going to tell you some size and you're just going to have to put numbers in. Next one. Geometric mean, this one deals with a leg. So that one dealt with an altitude. This one deals with a leg. Tell me the legs. I already told you. AC is a leg in this right triangle. CB is a leg. Draw that picture. And we're going to write down some stuff for it.
Does that say geometric mean?
Yeah, sorry. I'll do that. So on this one, make sure you're drawing this in. It says, if an altitude is drawn to a hypotenuse, then each leg, not both legs at the same time, but each leg is the geometric mean of the hypotenuse and the part of the hypotenuse adjacent to that leg. What's adjacent mean? Hook to, right? Adjacent, hook to. So when I draw this in, make sure you're drawing this. You got your altitude there. Not going to be able to do this stuff if you don't have this stuff written down. That's your altitude. We got part 1. Which leg is part 1 here adjacent to?
Part two. Or leg one.
Leg one.
Leg 1. Alright? Then we got part 2. Which leg is it adjacent to?
Leg two.
Leg 2. So that's the part you're looking at. If you're dealing with this leg, you're going to be using that part. And the whole hypotenuse. So our equation, I can move this out of the way. How you doing there? That's not good. Our equation is going to be that. The whole hypotenuse over leg 1, same leg, over the part that's hooked to that leg, part 1 down here. Now, does this picture always have to look this way? No, it could be turned around, upside down, whatever. All right? But notice,
Why do you have 2 leg one?
part that's hooked to. How come we have 2 leg ones? Because it's the what? Geometric mean. Those 2 and those 2 locations are always going to be the same. What's the other one I could set up? What if I wasn't dealing with leg 1?
Leg two.
Leg 2. So what would go here?
Leg 2.
Here?
Leg 2. Part 2.
Part 2. And that's what's next. And then there's one other one that I'm going to write up here just so you can get it written down. We could take the leg squared, whichever leg it is, whole hypotenuse times the part adjacent to it. That's just another way to write that same setup. Too hard, Silas? Think you'd handle it? You're just going to have to, they're going to give you a picture and you're going to have to pick out parts and put them in those proportions or in those equations where you think they can go. Now, are they going to give you on this, are they going to give you all 4 of these parts? No, there's probably going to be one of them missing. That's your assignment, 482. By using that thing that you want to keep a hood on all the time. See, I want you to take the hood off so you free that stuff that's in there. All that acid brain power.
Is it based off if it gives you the hypotenuse or not?
Just based off of what you know and what you're using. Pick me a variable. Z. So we picked Z. That's a leg, isn't it? So guess which theorem we're going to use? The leg theorem. Somebody tell me what does, give me 1 second here. Pointer options, pen. Tell me what the leg theorem says. Whole hypotenuse over leg
Is equal to leg over part 1.
over part 1. I'm just going to shorten it up and write it that way. Is that all right? So somebody tell me now, we're dealing with Z right here. That's what we're looking for first. We're just going to set up that proportion. What goes here? Z. What goes up here? Z.
9 and 6.
We want the whole hypotenuse. How long is that whole hypotenuse? 9, because you add those 2 together. How long is the part that's hooked to Z? Does everybody see that so far? We cross multiply. What's Z times Z give you?
Z squared.
Z squared. Multiply the other way. What's 9 times 6 give you? 54. Is 54 a perfect square number? No. I'll tell you what. On this one, let's just give the decimal answer so we can hurry through it a little bit. Take the square root of this side. You're left with Z. Take the square root of 54. What do you get?
7.3480.
7.3 what?
48.
So let's say 7.35.
I wish Josh
Pick me in. So that was a leg. Does everybody see how you pick which one you're going to use? Yeah, by what you're looking for. Pick me another variable.
X.
X.
That's going to be the altitude.
That's the altitude, isn't it? So which theorem are we going to use?
Wait, so is that
The altitude theorem.
Is that the answer to Z?
That's the answer for Z, 7.35. We're trying to find X. Where's that X go then?
Bottom left.
And
Top right.
now for altitude theorem, it's altitude and altitude here, part 1 here, part 2 there.
So 6 and 3.
6 and 3. Cross multiply, what's that give us?
X squared.
X squared, good. 6 times 3.
18. 3 rest.
Give me the decimal answer again. X equals what?
4.24.
Now, Josh used his calculator and he simplified it down in radical form. That would be all right also. Pick me another variable.
Y.
Y, leg or altitude?
Leg.
Leg. So which one are we going to use now?
Leg.
Leg theorem. What goes right here?
Y.
Y and Y, right?
9
Whole
and
9 and.
The whole thing is 9. Part hook to that is 3.
27. Y squared equals 27.
Y squared equals 27. Blake, it helps if you're watching instead of talking.
5.2.
Otherwise, you're probably never ever going to understand any of this. What's Y squared?
5.2.
Or Y, I mean, is 5.2.
5.
5 point what?
2.
2. Is that too difficult?
No.
Let's do the other one real quick. Pick me a variable.
Z.
Z. If we pick Z, now here's where you got to be careful because here's where a whole bunch of you are going to get confused. If we pick Z, Z is a part, right? So we could use the altitude one or we could use the
Leg.
leg one. We got to make that decision inside.
So,
Do I probably want to pick Z first maybe?
I would
Maybe
pick
not.
X first.
Pick X first?
Altitude.
X is altitude, so let's do that. That's X equals, maybe Cade was right, maybe we should pick Z. X goes there, X goes here, what goes here?
25.
What's the
25 minus Z.
25 minus Z?
You're gonna have 2 variables.
And then what goes here? Z goes there, right? Can we solve that? That's got too many variables in it.
Do Y.
So let's try Y. Y is a what?
Leg.
Leg. So if I'm going to use the leg one,
So 25 minus.
got Y there. We want the part that's hooked to the Y, which is this, which is 25 minus Z, isn't it?
2.
Are we going to be able to solve that? It's going to have too many variables in it again, so apparently Cade was right. He picked the good one. If we pick Z, it's the hypotenuse part. Well, we probably want to pick this leg right here. Where's that 7 go? Bottom there and top there. What's the whole hypotenuse?
25 minus Z.
Whole hypotenuse.
25.
25. What's down here?
Z.
Is that one that we can solve?
It would be
So sometimes it's going to be confusing. Sometimes you can solve one, sometimes you can't. Don't just give up. Pick another one and try to set up another proportion.
25Z is equal to 49.
25Z equals 49. What do you do to solve that?
Divide by 25.
Divide by 25. That's a Z, not a 2. Sorry, I'm trying to write backwards and it's not working very well.
1.96.
So Z equals 1.96. Once you know what Z is,
We can do all the other ones.
can we plug Z in back here?
Yeah.
This is 1.96. Get rid of that. That's 1.96. What's 25 minus 1.96?
23.04.
23.04. We cross multiply. Somebody help me out there. I know X times X is X squared. What's 1.96 times 23.04?
45.1.
And what are you going to do with that? Take the square roots. What's the square root of 25 or 45 point whatever?
6.71.
6.71. Now I'm going to tell you this before we go any farther. We could find Y using those proportions. What kind of triangle was the big triangle?
Right.
The right triangle. That's 7. This whole side over here is 25. What's the easier way to find that leg? Pythagorean theorem. Does anybody remember? Look at what we have here.
It's
25.
7.
Oh, it's one of the families.
It fits one of the families. Y equals 24.
I leave my keys.
But isn't the whole hypotenuse 25 feet?
No, the whole hypotenuse is just 25.
Oh, okay. That's what I heard.
Is that where we're messing up?
Yeah.
That's your assignment. Kate, go ahead and pull your desk back in here. Page 482. Make sure you write it down.